Welcome to today's lecture. In this video, I will discuss about the electron transition. When molecules are excited, the electrons go from a bonding to an antibonding orbital. When a molecules are excited, the electrons go from a bonding orbital to an antibonding orbital. Absorption of ultraviolet or visible radiations are sigma to sigma star transition, N to sigma star transition, pi to pi star transition, N to pi star transitions. And now first one is the pi to pi star transition. In this transition of an electron from bonding sigma orbital of a molecule to antibonding sigma orbital is called as sigma to sigma star transition. Transition of an electron from a bonding sigma orbital of a molecule to antibonding sigma orbital is called as sigma to sigma star transition. These sigma bonds are strong bonds and require high energy. These sigma bonds are strong bonds and require high energy. These transitions involve saturated hydrocarbons and there is no lone pair of electron in this transition. These transitions are studied in vacuum ultraviolet region. Sigma to sigma star transition. The transition of an electron from a bonding sigma orbital to antibonding sigma orbital is called as sigma to sigma star transition, and these bonds are strong bonds and required high energy and involves saturated hydrocarbons and there is no lone pair of an electron in this transition. These transitions are studied in vacuum ultraviolet region. And the next one is N2 sigma star transition. In this transition of an electron from a non-bonding orbital to antibonding sigma orbital is called as N2 sigma star transition. Transition of an electron from a non-bonding orbital to antibonding sigma orbital is called as N2 sigma star transition. This transition requires less energy than pi to pi star transition. Sigma to sigma star transition. These N2 sigma star transition requires less energy than sigma to sigma star transition. These transitions occurs in organic molecules that contains heteroatoms. This transition occurs in organic molecule that contain heteroatoms like nitrogen, oxygen, sulfur, etc. These transitions are studied in UV visible spectrophotometer. And the next one is pi to pi star transitions. Pi to pi star transition, the transition of an electron from a bonding pi orbital to an antibonding pi orbital is called as pi to pi star transition. Transition of an electron from a bonding pi orbital to antibonding pi orbital is called as pi to pi star transition. Pi to pi star transition. It contains double or triple bonds. Pi to pi bonds contain double or triple bonds and it occurs at longer wavelength. And these transitions occurs in near ultraviolet or visible regions. Pi to pi star transitions, the transition of an electron from a bonding pi orbital to antibonding pi orbital is called as pi to pi star transition. These contain double or triple bonds and it occurs at longer wavelength, and these transitions occur in the near ultraviolet and visible regions. And the last one is N2 pi star transition. Transition of an electron from a non-bonding orbital to anti-bonding pi orbital is called as N2 pi star transition. Transition of an electron from a non-bonding orbital to anti-bonding orbital is called as N2 pi star transition. This transition occurs, these transitions contain heteroatoms. These transitions contain heteroatoms like nitrogen, oxygen, sulfur and halogens, and these transitions occurs in the near ultraviolet and visible regions, and it have least amount of energy than all the other transitions. N2 pi star transitions, transition of an electron from a non-bonding orbital to anti-bonding pi orbital is called as N2 pi star transitions, and it have double bonds, and it contain a heteroatoms like nitrogen, oxygen, sulfur, halogens, etc., and it occurs at longer wavelength, and these transitions occurs in the near ultraviolet and visible regions, and it have least amount of energy than all the other transitions. Next one is the electrons. Three types of electrons involved in absorption of energy in the ultraviolet or visible region. Three types of electrons are involved in absorption of energy in the ultraviolet visible region. Three types of electrons are involved: sigma electrons, pi electrons and non-bonding electrons. Sigma electrons are saturated compounds. Sigma electrons are saturated compounds. Saturated means single bond, like alkanes. These electrons require high energy for their excitation, and these electrons are tightly held because sigma bonds are strong bonds. The compounds containing sigma bonds do not absorb UV visible radiations. That's why these can be used as solvents in UV spectroscopy. Sigma bonds are saturated compounds like alkanes. Saturated means single bond. These electrons require high energy for their excitation. These electrons are tightly held because sigma bonds are strong bonds. The compounds containing sigma bonds do not absorb UV visible radiations. That's why these can be used as solvents in UV spectroscopy. And the next one is the pi electrons. Pi electrons are unsaturated compounds like alkenes, alkynes and aromatic compounds. Unsaturated means double or triple bonds. And pi bonds are weak bonds. These electrons are easier to excite to the higher energy level, and pi electrons give absorption bonds in the ultraviolet region. Pi electrons are saturated compounds pi electrons are unsaturated compounds like alkenes, alkynes and aromatic compounds. Unsaturated means double or triple bonds. These bonds are weak. These electrons are easier to excite to the higher energy level. Pi electrons give absorption bonds in the ultraviolet region. And the last one is the non-bonding electron. Non-bonding electrons are not involved in any chemical bonding between atoms in molecule. These are not involved in any bonding between atoms in molecules. They exist as lone pair and atoms. They exist as lone pair and an atom like nitrogen, oxygen and halogens, like nitrogen, oxygen, sulfur and halogen. The next one is absorption bonds. There are four types of absorption bonds are there: K bands, bands, R bands, B bands and E bands. K bands are originated due to pi to pi star transition. K bands are originated due to pi to pi star transition, and it have high molar absorptivity and compounds containing conjugated system will be there. And the next one is the R bands. R bands are originated due to N2 pi star transition. N2 pi star transition, and it have mild molar absorptivity. And in this heteroatoms are involved and intensity is also less. And the next one is B bands. B bands are originated due to pi to pi star transition. In this heteroaromatic molecules are involved. Intensity is more than R band. And the next one is E band. E bands are originated due to pi to pi star transition, and it is further classified into E1 and E2. E1 and E2. Absorption bonds. There are 4 types of bonds are there. First one is the K band. K bands. K bands are originated due to pi to pi star transition, and it have high molar absorptivity and the compounds containing conjugated system will be there. And next one is the R bands. R bands are originated due to N2 pi star transitions, and it involves heteroatoms and intensity also less, and it have mild molar absorptivity. And the next one is B bands. B bands are originated due to pi to pi star transition, and it involves heteroaromatic molecules. Intensity is more than the R band. And the last one is E bands. E bands are originated due to pi to pi star transitions, and it is further classified into E1 and E2 bands. Thank you. If you like this video, please like, subscribe my channel.